Okay, so this is an annotation example for a pet finding test that is trying to test the pet finding behavior of the character that has a starting location defined as a 3D bounding box. Okay, we can find this green, so the character can be spawned in any of these areas marked here, either in this area basically here or on top of these boxes. Then the character has to move to one of these two entities located in the map with a starting rotation, and we also would like to test the before failure, before having to stay alert in failure cases. We put a threshold on the maximum time to get to the destination, like a maximum of 30 seconds, and he should not stay idle more than 3 seconds, otherwise we consider that the test is failed. So these are just the annotations. Okay. Yeah, so if the character would be spawned here, the expected path would be to get like in this area up to this point. If the starting location would be here, okay, then he would take this path up to the stairs and again the same movement. So let's see if our characters succeed and if there is any failure cases regarding these parameters. Okay, so this is the other path that the character will follow through the stairs, as I previously mentioned. Again, he will succeed to get to the destination. But as you can see, there is a failure cases here where the collision mesh is too big to enter to the door. And another thing, another failure case found is again where it's failing to go because of the collision mesh, and these are because of the character scale being too high. The two failure cases were captured inside the plugins folder inside outputs, failure tests, and in a CSV file with the same name as the blueprint test. So if you open it, you see the inputs that were produced by the fuzzer and the conditions that were failed, in this case the time to path limit. So the character couldn't find the path using this set of inputs. Okay. Then you can see here that the fuzzer actually scaled the character too much. First it was the first gate failure and this was the second gate failure. Smaller. Okay, so another really important thing is to show how to set up a functional test. On short, more details are on the paper. You can see here a blueprint example that defines overrides a template with three main functions. The setup context functions, which is in the behavior-driven development testing methodology, is the given context. The check triggers represents what needs to be put for the when clause, and the test correctness, which in this case will continuously try to find the path to the destination and either reach because one of the failure condition or succeeded if the character arrived at the final position is representing the then close. This is our visual tool to configure the path to the project for a particular folder that contains all the blueprints testable, the time that the test should run, the current status of the cluster, the user can configure the cluster to run on, then run all the tests that he selects over here. The tests are categorized by one of the areas according to one of the domains set by the users, and this shows the modified time. Okay, so this is one of the examples from the RPG open source project in Unreal Engine, where we try to find different class of AI difficulties. Basically what we have here is a blueprint that defines the difficulty of the medium AI class. It has some inputs like the hit rate, the sprint speed, the number of the initial potions, the number of jump spaces that the character has, as an examples. And then we have some expected outputs like the time to beat the easy AI system when playing against, and the damage taken. We have some ideal values and a standard deviation. The first one is using linear penalization, while the second is using a Gaussian penalization, where the penalization is the minimum for the ideal and the corresponding maximum for the maximum standard deviation. Then, as outputs, the fuzzer will try to find the best cases that respect to our conditions with the penalization factors, and you can see that in a very short time he finds three possible rows with different input parameters that the character should have, and then their corresponding outputs. This is another example from this sample in Unreal Engine, where a cinematic camera is driving through the world automatically and tries to detect performance issues like the frame per second and the memory occupancy of the process. So just to let you show the input parameters in this case, with the car density, the pedestrian density, the day and night cycle, like it's either day or night. Then the expected outputs, we call for the TPS and the memory footprint of the processes. Each are verified at each 60 frames, and we impose some limits on those values. When those values are exceeded, outputs triggered as failed will be generated in the Excel files containing the values, the input values that the fuzzer discovered, and the camera location, which was specified in our documentation like some debug output parameters. So these are defined as variables in the blueprints to assist debugging.